Okay, we're ready. We're doing this. Right.
Need a new book for the next video. Oh, what an intro.
Welcome, everybody. Okay. Your objective, one of the final things before you've got to do your test. Okay. Be able to multiply out. I would also say expand double brackets. Okay, expand double brackets. Now, for those of you that have gone on ahead with your homework or read in the book, you'll have seen these. Right? So what we're doing is we're extending from the single brackets that we've done. So if I said to you, expand 3 lots of 4x plus 6, okay, who is happy they would know how to do that if I asked you? Right, most people. I'm going to pick the ones that didn't have their hands up now. Nope.
So to put it into 2 brackets, you would...
I don't want to put it into 2 brackets, no. I just want to expand this. So get rid of the brackets, expand.
You would have to do... I think...
No, someone's got some revision to do then, haven't you? Louis?
8 times 4x by 3 and 6 by 3.
Yeah, so I end up with?
12x plus 18.
12x plus 80. Good.
You can also do it at the over the next one.
Yeah, we could do it as a table. Well, actually,
That's what I was
let's recap the table method because we're going to use that again with the double brackets if necessary. So if I had a box, split it. This side I'd have the 3, this side I'd have the 4x plus 6. And we multiplied 3 times 4x is 12x.
And 18.
And plus 18.
And you just put them together.
Stick them together. There you go. And this is the way, when we did a factorisation last time, was kind of doing it in reverse. Now, we're not going to get you to factorise back into double brackets yet. Not this year. But you will be able to. In fact, some of you might be able to do it after we've done this. So, what we're going to look at with double brackets then. So we have example like x plus 3 in one bracket, and not multiplied by a single number, but multiplied by another x plus 2, for instance. So if I said to you, expand these double brackets, okay, so we've got a couple of hands sneaking up, think they know how to do it. Izzy, what would you do?
What if you do x plus 3 and x plus 2 and then times 2x and 3?
So what do you think it would be? 6x squared. I can say no, it's not 6x squared. Sushi, what do you think?
To expand it, we would have to do we would add 3 and 2, which will make 5. So we'll get x squared plus 5.
So you think x squared plus 5 would be the answer?
No, wait. Yes, I think. Yeah.
Right? No, you're not correct, but you're closer than Izzy. Okay. Amol.
Would it be x squared plus 3x plus 5?
Even closer, but not quite there, Cammy.
No, so but would it be x squared plus 6?
You think x squared plus 6? You again, you're quite close, but no closer than Amol. Adam.
Is it x squared plus 5x plus 6?
There you go. She's got it spot on. It is x squared plus 5x plus 6. That would be the answer. Now, obviously, I'm not expecting you to just write the answer down and go, right, now I know how to do it. All right? There are 2 methods that I'm going to go through. All right? Let's go through this box method. right? So I've got the box, got one box. I'm actually going to put a second box now. Really, it's just because it's a 4-part grid. Okay. Now what we have doesn't matter which way round. I'm going to put my x plus 3 on one side, and I'm going to get my x plus 2 on the other side. Doesn't matter which way round, obviously, because it's multiplication. Okay. So first of all, does that make sense?
Yeah.
Yeah. So you're happy with why I put the numbers, and then we've just got to multiply. So x times x is the, and that's what all of you are pretty much saying. There's an x squared in there, definitely. Then I've got x times 2 is 2x. It's a plus 2x. We've got a plus 3x, and we've got a plus 6. And then we just stick it down. But actually, the plus 2x and the plus 3x combine, don't they? So we would have x squared plus 3x plus 2x plus 6, okay, combines to make that.
Just a question, if in an exam you put x squared plus 3x plus 2x plus 6, would that still?
No, it wouldn't be the final answer, no. You have to, at this stage, you have to collect and simplify. There might be a method mark, but not the final answer mark. Yes, Sushi?
Couldn't we write it as fully expanded and just expand? Like that would be an expanded form and that would be a fully expanded form.
Alright, I'll add something here. Expand and simplify is what you will see. Expand and simplify.
So this only expand that answer in acceptance?
Well, it's like saying, make me a dinner, and you give me some raw meat and a cabbage, and say, you didn't say I had to cook it.
Yeah.
Yeah. Really, it will say expand and simplify, but if we can simplify now, guys, we ought to simplify. Yeah, that's the deal for you. Right, that's one method. Now, some of you using that method might go, I've got a quick way to do it. Already, in my head, I've got a quick way. I don't need to do the box. Right, and if you've got that quick way in your head, then actually the factorization will become really easy for you. But before we go into that, I'm just going to go through it again, but using the method that I would call smiley face and eyebrows.
I have mastered that method.
Well, why did you get it wrong then?
Oh,
yeah.
yeah.
Big eyebrows. Okay, so the reason why, basically, you'll have seen from this one that everything has to be multiplied by everything. Okay, if you only multiply the x's together and the 2 and 3 together, you don't get the whole thing. So we just have to make sure, same way we did the lines, alright, I'm going to multiply x times x, gives me
x squared.
X squared. I'm going to multiply the x by the 2,
2x
gives me
plus 2x.
2x. I'm going to multiply this time the 3 by the x, plus 3x. And I'm going to multiply the 3 by the 2.
Those are a lot of smiles.
And I have a smiley face and eyebrows. Sort of.
Actually, I can't find any smile face.
Yeah, I think for me that's... Makes sense?
Oh yeah.
It kind of looks like it looks like in my book at least, it looks like the bits crossing over the x times x and 3.
Yeah.
Uniform.
Like mine. They're like the top of the hair and the brackets where they're together and the eyes. The brackets on the outside of the ears.
Yeah, I see the ears. I see the ears. It's kind of a space. Whatever method you need to remind you how to do it. Okay, I'm going to give you a few to do for yourself, so you can practice. Okay, I'll pause this. Okay, so there's a few for you to have a go. It should give you a full range. I'm actually going to add one more, just to expand it a little bit. We have.
Expand it a little bit.
Not yet, not the 3 brackets yet.
Are there 4 brackets?
Has anyone spotted a quick way?
Yeah.
Come in.
Well, I just do it.
I just
Just do it. Just do it. I just do x times x times 3, x times 7.
That's kind of the long way, but yeah,
I
that's
thought
fine.
it just
I
right.
just did it right.
I
Okay,
thought it
fair
just
enough.
right now.
Do she?
Maybe if we like add and subtract, over there, for example, there's -2 and +2. So instead of that, we can just do x squared, right?
No.
Wow. And I got it. Ooh.
Right, the one thing I use, so I can go straight, for instance, and go, well, this one is x squared plus 10x plus 21. Straight away, I don't need to do any work.
Yeah.
Okay. This one, for instance, I know straight away is x squared plus 3x minus 10.
Oh, yes.
The way I know that, okay, it's like this one. I know this one is x squared minus 8x plus 15.
Oh,
I know.
I
don't
so
know.
I've not done them.
I'm pretty sure.
Everybody's like, I know.
What do you reckon, Chloe?
Is it like you already add 2 numbers up
Yeah, and
then you just so instead of doing it twice in the room?
well, I think that's it. I know now this works mainly because I know I only have an x and an x, so I know that bit's going to be x squared. That's fine. And when I only have one x and an x, I know that this bit is these 2 numbers added together. So 3 add 7, and I know the number at the end is 3 times 7. That's it. Because if you look at what we did here, it ends up as 3x plus 2x. They just add together in the end.
Right.
So that's what I do.
Oh yeah.
Okay. For B, it's just -2 add 5, which is 3. -2 times 5, -10. -3 add -5. Oh, we all know how to do that. -8. -3 times -5 plus 15. So this one, straight away, we do, well, it's x squared
Plus 10x
plus 10x
plus 25.
plus 25. Now, I want to add something to this one. Okay? This one here, D, not A2 as Sushi was calling it. D, I would like you to recognise that. Well, actually, you tell me, is there any other way of writing, using the brackets, x plus 5 times x plus 5? Here.
X plus 5 squared.
Yes. Right? X plus 5 squared. Okay? Because when you multiply something by itself, okay, you can just write squared. It means the same thing. Right? Now this has a name that maybe you want to write down. Right? These, when they're like this, are called perfect squares. Okay? Perfect squares. Right? And we can look at the other form and recognise it because the 25 is a square number, okay, and the 10 is the number times 2. Okay? So other perfect squares would be x plus 1 squared, x plus 2 squared, and things like that. Okay? Alright, makes
How
sense?
does x plus 25 squared?
Obviously, yes. Right, this E is another example of something that we will grow to love and cherish and use in our mathematics. This one, well, what's the answer?
Is it x cubed minus 4?
It's not x cubed, no. Definitely not x cubed. So, yeah, David, what do you reckon?
X squared minus 4?
X x squared minus 4, yeah. Okay. Because
Oh yeah,
minus 2
0.
add 2 makes
Yeah.
0, so there's no x bit in the middle. Now this one is called, and maybe you'll understand why, this one is called the difference of two squares. Do you understand why?
Yeah.
Difference because of the subtraction. X squared is a square, and 4 is a square number. Okay?
I have no idea. Mamma mia. Can you get that answer?
So, if for those of you that didn't know that answer, if you expand x, let's do x minus 5, x plus 5. Now, so we recognise it by the fact it's not squared, like someone said earlier, it's minus but plus with the same thing. So if I multiply that out, x times x is x squared, minus 5x, plus 5x, minus 25. Now obviously minus 5x plus 5x
0.
ends up being 0, and we have x squared minus 25. Right?
Okay.
Now that is a very, very useful thing to remember when you need to factorise, when you need to go back the other way. Again, it's not a problem for you at the moment, but I'm kind of putting the seed into your brain. Alright,
Cool.
finally, this one is slightly different because, is it? Yeah, it's not just an x squared, that makes it a little bit different. It means we have to do our working out really. Sushi?
So can it be 5x squared?
So it would be 2x times 3x is not 5x squared, it's 6x squared. Then we do plus 2x, okay? And then we've got plus 3 times 3x is 9x. And then finally, plus 3 at the end. So we end up with 6x squared plus, excuse me,
11x
11x plus 3. Okay? Makes sense? There's a couple of things there, perfect squares and difference of two squares. If you can, you don't have to commit those to memory, but if they can start, add those to your memory palace, as they call it. I don't know if you watched that on the show. Yeah. Stick it in there, and one day you'll be asked to recall that, and you'll be like, we have talked that.
How do you factorize them?
Well, okay, just out of interest. If I said to you, factorise x squared plus, what should I do, 7x plus 12, okay? Because of the shortcut way that we've been working on, right, we know from this, because there's 3 parts and no common factor, that we are going to try and factorise into 2 brackets. And because it's x squared, we know it's x and x. Now we follow our other rule, which is the 2 numbers multiplied to make 12. So it's either 1 and 12, 2 and 6, or 3 and 4. But only one of those pair add up to make 7, which is 3 plus 4. Therefore, it must be plus 3 plus 4. Now you don't need to write that down unless you really want to. It's up to you. That's not something you're going to be tested on. Just to give you the reasoning behind the difference of 2 squares thing. If I said to you, as will in the future, factorise x squared minus 49, Alright?
Oh,
Unless you remember the difference of two squares thing,
is
you're
it?
going to say it doesn't factorise because there's not three parts. Now I said to you here there are 3 bits. That leads to double brackets. It's not got 3 parts. There's no common factor. So we've got all that. However, because we remember it's the difference of 2 squares, Amor,
It'll be in brackets x minus 7 and x plus 7.
okay? So it's one of those things where if you don't remember the difference of 2 squares, then you're going to struggle. So, for a dragon,
Okay.
Oh,
factorise 4x squared minus 9. You get 1 shot at it. Come in.
It'll be brackets 2x minus 3 brackets and another brackets 2x plus 3.
Well done. Straight in there. Congratulations, Cammy. I owe you a dragon. Yeah.
yeah, it does.
Anyone want to give me the answer to? Let's do. Got to give me the correct answer straight away. Kian.
3x minus 4. In one bracket and we get 3x plus 4.
Do you agree?
Yes.
Yeah.
You do?
I do.
Yeah. What?
Wait.
So he said 3x minus 4. 3x plus 4. Yeah? Is that what you think?
Plus and minus.
Any comments? Yanbi, what do you think?
Would it be 3x plus 4 against that?
Oh yeah.
Oh, yeah.
What do you
Would it be 3x plus 4 squared? No. 3x plus 4 squared?
Yeah,
Yeah.
yeah.
think?
But
You put my hand up, just say no. Right. What is the difference between this one and this one? Sushi?
Both sides should be plus.
No.
No.
You're trying to use the rule for doing the, what's it called again? The difference of
Between-
2 squares.
yeah.
You're trying to use the difference of 2 squares. The difference must be subtraction. This is addition, therefore, sorry, no. Okay? If I said to you factorize this, you would say to me, it can't be factorized. Alright, can't be factorized. There's no common factor. It's not 3x plus 4 times 3x plus 4 because where's the middle stuff with the x's? Okay? This one would not be factored. That's where, as you get more experience, you'll go, oh, right, that can't be. But that's the kind of thing that, unless you're really switched on, you'll forget.
What
Okay.
if we use 1 as a factor?
Well, you can, but why would you bother?
You just do that and
He would.
If I factorise it to be that, I've not done anything.
No, not like that. Wait, what if you write like
Right? You don't take 1 as a factor out because that doesn't change anything. Anyway, guys, can I ask you then? So based on what you actually need to do, which is multiply out the double brackets, give you a bit of practice. It's quite good actually. You've got the factorisation bit, but that's kind of a couple of years ahead of what you need to be really. But you guys have got that. So in your book, all right. So if you were to turn to page
140.
where are we again? Yeah, page 140. Page 140, questions. If you have a go, questions 5, 7, and 8. 5, 7, and 8. Okay.
I didn't get the one.
Right, guys, let's just check one thing. You seem to be. Oh, I don't know. Which one are you kind of thinking about?
5A.
So, what's the question? Read it to me.
X minus
X
1
plus 1
brackets squared.
Okay. I just want to tell you one thing. Okay. Now I have my little saying for this. Please, 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 do not do this. 4x squared plus 1. That's not correct. It is not correct. Alright, put your hand up if you did that. Okay. It is not. You do not do the squared to the 1 and the squared to the x. If you remember, one of the things we talked about was x minus 1 squared is x minus 1 times itself, which becomes x squared minus 2x plus 1.
You were
Okay.
too.
On that happy note, off you go. See you later.
Okay, that's